So what? You might say. If we saw something like this, right here, 4x plus 1 over 5, well, we could express it as exactly what we just saw, 4x over 5 plus 1 over 5. Because remember, that's just doing almost the reverse of what we did. If we were to add these two fractions back together, we'd get the numerators added together. That's 4x plus 1 over 5. And we can also go the opposite way. So let's rewrite 2 over 9 minus 3x over 9 plus 13 over 9 as a single fraction. All we're doing here, once again, is we're just adding and subtracting the top numbers, the numerators, and putting them all over that common denominator. So up top, we would have 2 minus 3x plus 13, all over 9. These two expressions represent the same thing. And the beautiful part about it is that that's how we split up these types of fractions that have numerators with multiple terms in them. Remember, terms are just simply separated by a plus and a minus. We've got 3 terms on top here, and it's all over a single number. So if it's all over a single number, we can split it up to however many terms there are. Now we have everything we need to tackle our second example. We have that we need to solve for x in the equation 4x plus 1 over 7 minus 5 equals 2x plus 3 over 9. We just saw that if we have a bunch of terms on the numerator over a single number, we can rewrite this as 4x over 7 plus 1 over 7, and the 5 stays the same, and we can split the 1 on the right hand side as 2x over 9 plus 3 over 9. And these represent the exact same equation. And you can probably see now that we're in better shape than we were before, because now the x's are slowly coming apart from the numbers. And if we were to continue along here, we'd want to get this 2x over 9 over with the other x term. So we would have 4x over 7 minus 2x over 9. And while we're at it, let's get these constants, or these numbers, over to the right-hand side of the equation. So 3 over 9 is already over here. The 1 over 7 is a positive number on the left side, so it becomes negative on the right. And the 5 becomes a positive on the right-hand side because it was negative on the left. Okay, we're a little bit closer. Remember, we can represent this 4x over 7 as 4 over 7x, just like we did in the first example. And this 2x over 9 we can write as 2 over 9 times x, or 2 over 9x. And the right-hand side, I'm going to start actually finding a common denominator, because I know that I'm going to have to add and subtract some fractions here. So a common denominator amongst these, we know that the 5 is actually 5 over 1 if we want to represent it as a fraction. So a common denominator would be 63. And we can do that. We can get 3 over 9 with the denominator of 63 by multiplying top and bottom by 7. This 1 over 7, we can multiply top and bottom by 9. Remember, we're not changing the fraction at all. We're actually creating equivalent fractions, just ones that are easier to work with. And of course, well, this 5, we have to multiply top and bottom by 63. And I don't know 63 times 5 at the top of my head, so on the right-hand side here, I'm going to do a quick calculation. So that's 315. Okay, perfect. And this next step, we can sort of work on the left-hand side and the right-hand side at the same time. So I'm going to subtract 2 over 9x from 4 over 7x. So on the right hand side here, I'm going to do 4 over 7 minus 2 over 9. And I'll find a common denominator, and in this case it's 63 again. So multiply the left fraction by 9 and the right one by 7. And we have 36 over 63 minus 14 over 63. And that leaves us with 22 over 63. Perfect. Okay, so we have 22 over 63x equals 21 minus 9. So I'm just solving the right-hand side of the equation now. 21 minus 9 is 12, plus 315 will be 327 over 63. Perfect. Okay, and once again we have some number times x equals some other fraction. So what we need to do is we need to separate that x. So we'll divide both sides by 22 over 63. And that will get rid of this 22 over 63 attached to the x. So our next line would be x equals, and what I'm going to do is I'm actually going to flip this division right away. And we can continue on here. I see 63 is going to be a factor in both. So x equals 627 over 22. And I'm not 100% sure how many times 6 over 27 goes, or sorry, 622 goes into 627. But if we were to kind of complete this, oh sorry, this shouldn't be 627, this should be 327. Thank you for catching that, students. Sorry about that. There we go. So what we end up with is 22 goes into 327 14 times, and there's 20 seconds left over. So that would be our answer for that one. Next question. Example 3. This is our last example. So if we wanted to solve for x in the equation 4 over x plus 3 over 2 equals 5 and 1/8, we see here that the x is actually on the bottom of a fraction. And this is kind of ugly, but let's say this is on a test and your mind goes blank. Just remember what it is we're trying to do here. So do as much as you can, and by that I mean at least we know we need to get the x by itself. So one thing we should know how to do is let's at least get the number to the right hand side of the equation. So we've got the 4 over x. We don't really know what to do with that yet, but we're going to move that 3 over 2 to the right hand side of the equation. Since it's positive on the left, it'll be negative on the right hand side. And I'm going to change 5 and 1/8 to an improper fraction to make this look a little better. That would be 41 over 8 minus 3 over 2. And the next line, I can still continue on the right hand side here without dealing with the left hand side for now. But I need a common denominator if I'm going to subtract these two fractions. And we can probably already tell that our common denominator is 8. And I would just multiply this right fraction here by 4, top and bottom. So that would give us 41 over 8 minus 12 over 8. And that would leave us with 4 over x equals 41 minus 12 is 29 over 8. But what now? Here's a nifty little trick. We can actually cross multiply. And some of you who actually remember what this means is we would multiply diagonally across this equal sign. So it'll be 29 times x and 4 times 8. And after that, we can carry on. So that's one nice little trick when you see a scenario just like this. When you've got a fraction on both sides of the equation, you can multiply tops and bottoms diagonally. And to finish this off, we need to divide the left-hand side by 29. And what we do to the left-hand side, we have to do to the right-hand side. So we're left with x equals 32 over 29. Or as a mixed fraction, we have 1 and 3/29. So that's the answer to that. But before we go, I want to just repeat myself here. If you see a scenario like this that we had just seen, you can simply cross multiply as we had just done across that equal sign. And it will also work in scenarios like this one, where let's just say, for example, it was x over 4 and 29 over 8 on this side. It would still work the exact same. You would cross multiply, and you would have 8x on one side. That would be 8 times x equals, and 4 times 29 on the other side. And that would be 116. So no matter what sort of setup it is, if you have a fraction on the left-hand side of the equation and a fraction on the right-hand side, in either of these cases you can cross multiply, and that's really just a really neat trick to get to something that looks a lot nicer. So let's summarize what we've actually learned today. So we're done all the examples. The first thing that we have learned is that we can split up a numerator just like this. So if we have the top with multiple terms, and the bottom is just a single term, we can split it up into each of the terms, separated by the same pluses and minuses that we would see on the top. And these represent the exact same thing. Here's another thing we've learned. These are all equivalent expressions. We could write 3x over 7 as 3 times x over 7. We know that because 3x is 3 times 7. We could rewrite this as 3 over 7 times x over 1, because let's face it, this is simply the top is 3 times x and the bottom is 7 times 1. And that we can represent as 3 over 7x. The gist of it in this particular lesson was that these two on the end are equivalent. And remember, sometimes it's advantageous to have the one on the left. For example, when you cross multiply. So that's the last thing that we learned, was you can cross multiply in scenarios like these. So in a scenario where you have two fractions and the x is on the bottom on one of them, or two fractions and the x is on the top. It really doesn't matter. But you could even have something like I said, 3x over 7. And this is when it's advantageous to keep it in that form, is when you have sort of a fraction on both sides. It's not as easy to see if you had wrote it like this. So sometimes it's nice to keep it in this form, especially if you want to cross multiply. And in that case, just because we're already here and talking about it, this one would be 3x times 4, that'd be 12x. And the right-hand side would be 7 times 1, which is 7. Neat, right? Yeah, I thought so too.